Good morning, everyone. So like Rob said, today we'll be talking a little bit about new updates for TI's comparator portfolio. So thank you all for tuning in. And without further ado, let's get into it. So the agenda for today is pretty straightforward. I'm going to go through a few updates to the comparator portfolio, talking about some of our new processes as well as new developments in areas like high voltage, low power, and general purpose comparators. And then I'm going to round it out by going through a couple of key application areas for the comparators. So namely, we'll be talking about some value diagnostics, motor control, and smart meters. So to start off, just from a high level, I wanted to give everyone the big picture of how TI is really investing in standard products. It's really in four key areas, right? So first, as a supplier, TI has unmatched supply, and that really comes from our ability to develop products on the 300 millimeter wafer, right? So perfect continuity, perfect support, as well as we can do it through that technology. The second thing is our diverse portfolio. So in terms of industry standard, TI has the largest comparator portfolio out in the market, and that portfolio is split up into multiple categories that we actively invest in, right? So low power, high speed, high voltage, etc. Each of these devices, and as we're seeing on top right, each of these devices really comes in a variety of packages, which include the industry standard leaded and leadless packages, as well as the smallest packages we can offer. It's actually the world's smallest comparators in industry today. And lastly, our performance is quite superior in terms of our speed to power ratio. So we have high voltage devices that go up to 40 volts. We have high speed devices with propagation delay in the sub nanosecond range, as well as low power devices that go down to 75 nanoamps. So you can see the investment for comparators for TI is far more than just our standard comparators, right? It's a very diverse portfolio. But what I'm going to talk about today is really a couple of new products to start with. And that's really, I'm going to focus on three products to keep it short and simple. The first is the LM393B and LM2903B. This is a modern refresh to one of our industry standard comparators that we've been selling for the past 40 years. Then I'm going to discuss a little bit about this TLV7032 and 42. This is a new nano power comparator family that really focuses on low power and small size. And lastly, I'll discuss the 170X, which is our kind of high voltage, high performance comparator family. So if there's one thing that you could take away from this presentation, I think it would be this slide right here. This is our improved LM393B and LM293B family. And you can see I've highlighted the differences between the B versions of these devices and the regular versions in these red boxes. And as you start going down these specs line by line, you'll notice that it's really enhanced performance across multiple parameters, right? So we are extending the voltage range to 36 volts. We are extending the temperature range, right? For both LM393 and LM293. We are cutting down the offset voltage. We are decreasing the propagation delay, reducing the current, and all at the same time bumping up our ESD to 2 kV. So really what we're doing here is taking the same technology that has proven so successful for the past 30, 40 years and renewing it and redeveloping it on our latest process technologies. So these devices are going to be rolling out slowly over the next couple months, all throughout 2020. You can see in the bottom left that we are going to maintain the exact same package availability for these new devices from our old devices. So it'll be very easy to kind of drop in the upgrade if you're currently using one of these parts. I'd also like to note that we are not at this time planning any type of obsolescence for the older devices, right? So the LM393 and 293 that you may be using today will still be on the market, no change. If you were looking for a slight performance upgrade, then you can consider the B family. You'll notice this B suffix, really, in this case, B stands for better. And this is not just a TI comparator move, but you will see this suffix applied across the amplifier portfolio. So even in the popular LM358s, 324s, you'll also see B versions. And the same way, you will see this B version for our LM393, 293 comparators. These two specifically, the dual channel devices, are currently sampling right now. They're on the web. Soon you'll notice more and more of the B family start to pop up for the quad channels and the single channels of the similar kind of standard comparator variants. This is very exciting, something that we are hoping this B family will, pave the way for the next 40 years. It's really TI's commitment to, supplying to our vendors and our customers for the next couple of decades. Now, this next family is a little bit different. This is our new small size and nanopower comparator family. This is the TLV 703X and TLV 704X. So I've highlighted the two key specs. So first, notice this is a 5-volt device, right? So typically meant for lower voltage rails. But the key spec here is the quiescent current, right? So 335 nanoamps of quiescent current per channel with a propagation delay of 3 microseconds. So that ratio there is actually quite good compared to industry. And in addition, we have this family available in different flavors, right? So you'll notice that, for example, open drain outputs, you can look at TLV 704. For a push-pull output, you can look at TLV 703. That's completely up to you on your design preference. Both of these products are available in standard leaded and leadless packages, and I've kind of outlined that there in the bottom of that top left box, right? So for single channel parts, we have a very small space-saving SC70 package, even a leadless X2SON, as well as a standard SOT23. And for the duals, we got a VSSOP out, and we are about to release a DDF package and a WSON. The DDF package is a new leaded package from Texas Instruments. Again, you will start to see more and more of these pop up. Some of them have already popped up, and essentially they are a slightly smaller version of an SOIC that can actually fit into the SOIC footprint. So no layout changes required, but it will save you power dissipation and cost because of the smaller size. Now, one other thing that I'd really like to point out about this family, and this is something true that will be ongoing for all of TI's new comparator developments. We've taken this input directly from customers we've spoken to in the field, and we've developed something into all of our designs now that we call POR, which stands for Power On Reset. So Power On Reset is essentially a way for you to know exactly what the comparator output will be as you ramp up the supply to your comparator. So let's look at a quick example, right? So this device here has a supply range from 1.6 volts. So the common question that we typically get from our customers is, okay, I can use this device at 1.8 volts, but what happens until, while I'm ramping up my supply up until 1.8? What's the comparator output going to be? And a lot of the times, if you look at older TI devices or even competition devices, you'll see that comparator output is not well defined. And depending on external circuitry, that output can be high or low. And in some cases, it could even blip from high to low or from low to high. So that, of course, is not a stable environment, especially if you're using a comparator to control some kind of downstream FET, and you don't want to just connect system to power when you are intending to. So with POR, we force the output low while you ramp up the supply. So you know exactly where the comparator output is going to be. And this is really a fault tolerant way to provide stable operation. Even if there's noise, we have built-in hysteresis. So the device will not switch until it's in the operating range, which we set at right below the recommended supply voltage, right? So around 1.4, 1.5 volts, the comparator will start to mimic the input, and then it will act as a normal comparator. So POR, we think is a very exciting new development. We will be including it in all of our comparator devices moving forward. This family here is quite recent. It's about 1.5 years old. It was the first family to include this circuitry. And it's proven to be very, very effective just for designers to have peace of mind, right? So okay, my output will stay here. I don't have to worry about power sequencing when I'm using a device like this. Now, this next family, okay, so it looks very similar, right? I'm going to quickly just page back and forth between the last two slides for you to see the differences here. And if you just focus on, the two red bullets, you will start to see essentially all that we have changed here. And this is a simple dial that we control while designing, is the quiescent current to propagation delay ratio between the nanopower family the micropower family. So here, our quiescent current is 5 microamps, but what does that buy you? Well, by biasing our transistors a little bit faster, putting more juice into our circuit, we can get a little faster propagation delay. So here you have a pretty quick response time of 260 nanoseconds, which compared to the nanopower device was at 3 microseconds. Right. So again, same package options. You have your your duals and single channels, and this also includes the POR circuitry. It's a 5-volt device, push pull and open drain. Right now, all I'm giving you is a micropower option and a nanopower option. So this combination, this TLV 7000 family, is really our kind of flagship low power comparator family. And because again, it's built on our latest process technologies, it doesn't mean that just because we're getting this down to nanopower range, there's an incredible price premium here. These are still very competitive pricing in the market. And for 5-volt rail applications or even 3.3-volt rail applications, I would completely recommend considering these new devices because you really get the best of both worlds in terms of the size and the speed to power ratio. All right. And the final new device that I'll speak to today, this one is pretty interesting. This is the TLV 1700X high voltage family. And you can really think of this as, okay, suppose I'm using the standard LM2903s or LM2901s, maybe even TL331, right? Those standard comparators today. This family is meant to be a direct upgrade to that family, a full performance upgrade. So you can see it's upgraded in a couple of key specs, right? So yes, it works up to 36 volts, similar to your LM2903s, but the key here is the quiescent current. You're down to 55 microamps, right? So compared to one milliamp in our standard comparators. So much lower power, much faster speed, about 2 times faster at 560 nanoseconds. And another key spec here is the low input offset voltage, as well as rail-to-rail inputs. So I'll speak a little bit more about how the rail-to-rail inputs really provide value once we discuss some of the common comparator applications. But this, in all senses of the word, is a full upgrade to the LM2903. So you can look at it 2 ways. If you're using LM2903 today or LM393, right? TI standard comparators. We have the B family coming out, which the 2 dual channels are already sampling today and available. That will be your kind of small step upgrade to your existing parts, right? That'll be the best supply, and it'll have slightly improved specs. If you're looking at those devices and you say, you know what, those standard comparators just really aren't doing enough for me in my system, I need lower power or I need faster response time, then you can consider this family. It still works at the same voltage levels, so you have no sacrifices there. And again, you can see in this bottom left, we are offering the device in multiple packages, right? So you can see we got the SON23 SC70 for the single channel. We have our VFD for the dual channel, as well as the leadless option, if that is the case, as well as the standard kind of 14-pin TSSOP. I will say one thing: the TLV 1702 in the leadless package, that QFN, does have a pitch of 0.5 mm. So we have seen that it is actually a very popular choice among industrial designers who want to save on space, but may not have that manufacturability to go and build really, really, really small pitches. So we still maintain that 0.5 mm pitch, which makes this part pretty valuable. So that was just a quick summary, right, of our new products that we've been releasing, right? So you can see a lot of investment happening in a lot of different areas. I'm going to take the next couple of minutes to quickly go through some of the common areas that we see comparators from TI's perspective, and how we can help you design better with these devices, right? Some new ways you can use them. So standard bread and butter. This is probably the most common comparator application in the world. It is simply just monitoring a power supply or battery voltage. And here's what I've noticed. If you're coming from a power background, an analog power background, you'll typically think of, okay, when I need to monitor a voltage on my system, I could look to use a supervisor of some sort. And then I've noticed if you're more from analog signal chain background, that tends to shift towards amplifiers and comparators. But really, depending on the type of voltage you're monitoring, you could use either solution, right? So here I'm showing two different ways you could do voltage monitoring with comparators. The top left there is using a high voltage window comparator. So window comparators are great because we will integrate a on-chip reference. In this case, it's a very accurate reference. It deviates less than 1% over temperature, right? So we integrate that reference for you, and then we provide two outputs that you can OR together and get a signal for, okay, when is my signal in between these two values? It tells you, okay, look, for example, I am, under 10 volts, but above 6 volts. I'm in that power good range. That's the output that I want. Now, the bottom right picture there, the TLV7042, that's showing a similar window comparator, but where the reference is set up discretely through a resistor ladder. You can work either way. Really, the way we tell our customers to design is there a reference available on your board? If there is, then you don't need a comparator. You don't need to pay for that integrated reference like 6700. But if there isn't, that is a very convenient option, right? Because it saves you space, it gives you precision, and it makes your life a lot more convenient because it's an autonomous voltage monitor. But regardless of the type of voltage monitoring you're doing, you'll see that TI has the devices in either voltage range and either power range to really meet your needs. Now, the second application is a little more unique. I think high-side current sensing is something that people don't normally look to when they think about comparator devices, right? And again, they focus on the voltage monitoring. But current sensing is a huge deal for comparators. And really, what differentiates a comparator from a current sense type of application versus a voltage monitoring is voltage monitoring is very DC, right? If I'm monitoring a battery voltage, it's not fluctuating at a very fast rate. So I can typically, depending on the voltage I need, but I can typically optimize my system for a slower response. And what that buys me in turn as my customer is a much lower power consumption, right? So it becomes like a nanopower or micro power autonomous voltage monitor. That's one common usage case. But for current sensing, you're looking for a quick response, right? Faster than an ADC would give you, or faster than a transimpedance amplifier alone. So in this case, comparators with quick propagation delay are the key heroes here. And I've shown two different ways that I've seen my customers typically deal with current sensing using a comparator. And the first at the top is very common. You have a shunt resistor, a current sense amplifier, and then a comparator. And that comparator just quickly kind of sets an alert signal. It gives you a quick, okay, my system has now hit an overcurrent condition. Please let the microcontroller know. Now, this bottom picture is a little more unique, and this is really for you guys out there who are looking for a quick and cost-effective solution for a simple current threshold. You can just use one comparator on the high side, right? Set a resistor divider down there and monitor voltage across that shunt. And depending on the type of comparator you use, again, you would like to make sure that it's spec for the speed you want for your response. But that comparator output and that overcurrent alert signal you can see can go into a variety of places in your system. And that's what this middle box is showing, right? I can go to a microcontroller and set up an alert. I can go and shut down a DC or DC converter. Or, and this is a more unique case, I can go and drive a MOSFET directly and then simply open or close, separate my system from my power whenever I need. And again, you look on the right side, we have devices that kind of hit all these spaces. If you're doing high side current sensing, we typically do recommend that 17OX family that I mentioned earlier because of that 36 volt rail trail input, right? If you're sitting at the high side and you're dealing with those higher voltages, you really want that full input headroom to monitor your signal. And that's where rail to rail comes in advantage, and that's where the standard LM290X devices fall short, right? Now, if you want a reference, like I'm showing the top left picture, here are the devices. We have the 40X one, which is kind of our 5-volt family of reference, and then the higher voltage ones, like I mentioned earlier. So again, depending on the type of current sensing you're doing, we do have the options either with reference or without, either high voltage or low voltage, all for you to pick from. And lastly, these are some quick applications. I'm not going to go through the exact details of the comparative function here, but I'd just like to make a few quick points for anyone interested in servo drive or in motor drive. Comparators are typically used here for sensing the rotor position. And again, you can see, just pay attention to this bottom left bar. The idea is TI has devices that will help you design for whether you're developing, a standard encoder where the speeds are a little bit lower for response, or a faster one or more precise one. We have our standard comparators that are perfect for that application, or we even have higher speed 40 nanosecond type devices for a higher speed encoder. And for each of these parts at the bottom, you can see we do have a lot of nice collateral on the web that can really talk to, okay, how do I, walk me through the steps? How do I actually set up my zero cross with the comparator? What are things I need to look out for? And then a full TI design on the actual encoder interface itself. And a similar thing holds true for our power stage modules. So this is again very common comparator application. If you have any motor in your system and you're doing some type of current sensing, right? Typically you will have a current sense amplifier of some sort in there, or you might be using an ADC, or your integrated driver actually handles all this function. But if your driver does not handle this function, we always have seen comparators in there that do the quick overcurrent detect, right? And again, look at the top left box, or sorry, bottom left box, right? You see standard devices. If you have a no real hard limit on how quickly you want that alert to come out, if you have a requirement for the speed, like, okay, I want my system to alert me within 10 microseconds. I want, within 10 microseconds of my overcurrent alert, I want to be alerted and I want to shut down and, lower power to the FETs. Then you look at the higher speed devices, right? And again, the collateral at the bottom, high speed overcurrent detection and the high side current sensing, just tips, tools and tips on how to design this with a comparator. And then the last kind of application area that I'll speak to today is just in the metering space. So motors typically are either standard comparators or this kind of higher speed family. In the meters, it's more of this low power is what we've seen. And one of the common areas I've seen, this doesn't apply just to meters, but anywhere you have a IR circuit, some type of IR receiver on the front end, we have seen a comparator sit there on the front end. And if you bias that IR LED high enough, you can actually, let's say you bias that thing so the drop across it is about 50 millivolts, then you don't even need a transimpedance amplifier. You could just have a comparator sitting there and detecting when that diode has a signal, and that will give you some kind of alert. It'll let you know when you're communicating with your heater. So again, we see standard comparators used here or low power. Collateral is there at the bottom, right? And lastly, in metrology itself, sometimes depending on the type of meter people are using, the main application here is time of flight. So again, on the receiving analog front end for time of flight systems, after the photodiode and the TIA, we typically see a high-speed comparator that drives a TDC. And that is what that image block diagram here is showing. So TLV3501, TLV3201, these are high-speed comparators. These are in the nanosecond propagation delay. These aren't per se very new devices. They're about 3 to 5 years old, but still very competitive in the market. And I've also included that 7011 to 260 nanoseconds. So really, you have your play of the pick of the litter. You can really pick anything as fast as 1 nanosecond all the way in the microsecond range. And I will end today just by giving everyone just a quick reference because we will be sending out these slides. So it's nice to have everything in one page. This is just the hero devices that I was speaking to earlier on the left, just kind of categorized by the low power, high speed, high voltage, etc. And the really interesting thing is this circuit cookbook list on the right. So the circuit cookbooks is a new kind of TI amplifier and comparator approach to helping our customers really get to the nitty-gritty of how to design with our devices. So you can see we have a whole slew of different circuit cookbooks on there. And here's just a quick example of how these cookbooks look and how they can help. So the understanding here, what we're going for, right? Our goal is to give you all a quick design guide, very short. Each circuit cookbook is about 3 pages or less. Sometimes we include simulation screenshots, and that makes, add some space in there. But the meat of it is 3 pages or less, so much shorter than a typical app brief. And our goal here is to just show you a quick solution with one of our parts and what design notes to be wary of when you're trying to design something like this. So you can see on the left, I have a list of a bunch of different comparator tricks you can do, right? There's a thermal switch. There's zero cross detection, obviously voltage detection, current sensing, clock restoration. All these are common applications that you can solve with a simple comparator. And you can see on the right here how those examples look, right? So this example on the right is actually showing how to set up a thermal switch with one of our devices. So again, you can see we have an NTC and then a resistor ladder setting a reference, and then a comparator just monitoring for when that temperature goes out of range. And the second it crosses your threshold, right, it's a switch, it will go and alert either your microcontroller or you could drive a MOSFET. And actually, in this case, this is probably one of the most cost optimized thermal switches you could create because NTCs are pretty darn cheap and can also come at a pretty nice cost. So this NTC thermal switch idea is very common. So we decided, okay, let's just put up a design guide out here, show people how to design. And an example of some of the tips we would give is, okay, we know temperature, again, is not a fast moving signal. Temperatures change very slowly over time. So when I'm optimizing a comparator for temperature sensing, why not optimize for lowest power? When I'm burning the least power, I have a slower response, but that's totally okay for temperature sensing. So we're highlighting that new nano power comparator here, the TLV7041. You could just as easily have chosen a standard comparator and burned more power. That's really design choice up to you. But the way we see it, if you're gonna optimize your design properly, it would be nice to just get the lower power when you can. Right? So little tips and tricks like that. That's what we have included in these circuit cookbooks. They are a very, very exciting new development. I believe today and each of these links, by the way, are hyperlinks, so you can actually click on these and head to see the cookbook for yourself. I believe the comparators that by ourselves, we have about 20 different circuits online. And the amplifiers as a whole for TI, we have another, I would say, almost 80 circuits. So almost a grand total of about 100 little designs out there, spanning general purpose amplifiers, high-speed amplifiers, precision amplifiers, comparators, and more, right? So it's really TI's push on the amplifier and comparator end to really give our customers the best collateral support we can give. Of course, you can feel free to talk to your field applications engineer or sales engineer for any other information or other collateral that goes in more detail beyond this, as well as if you have any questions about the parts that I just went over. So that I have some additional hero products here, but for the sake of time, I'm not going to go through them. They just include some high-speed stuff. They will be in the slide for reference. We do have new product updates on our website on the training portal. So that link is right here for everyone to see. And lastly, here's just a list of the upcoming broadcasts that we'll be showing.